Hi there, this is Dr. John, your physics and math professor. We're now starting to work on different types of transformations. I mentioned that in the previous video. So here I've given you a couple of quick examples. We can stretch a function. You can think of the purple function as being stretched here to this yellow function, or we can squeeze a function by taking this yellow function, squeezing it back to the purple one. Or here we've stretched the purple one up to the yellow one, or we can reflect it. That's the second type. Like I said here, over the x-axis. It's like the x-axis is a mirror. That's called a reflection. Those are the first two types. But today we're going to start to look at what's called translations or shifts. Now we could think of this as a shift. We're taking this function here, shifting it over to here, or we're taking this absolute value function, shifting it up in that way. But we don't like to use the word shift because we've already got one S word here in stretch. And we want to be able to remember these: stretch, reflect, translate. You can use the word sort if you want to. The letter O isn't found in this, but the S for stretch, the R for reflect, the T for translate, we're going to do them in that order. So that's why we don't use the word shift. We'll use the word translate. I know the word translate is a little bit unusual. It's maybe one that we wouldn't use in a sense like this. And in the English language, we tend to use words in multiple different ways, and then in different ways altogether in the scientific talk. For example, the word normal. If this is a surface, here, a flat surface, and this is a line that's perpendicular or at 90 degrees to that surface. This is called the normal line. Normal just simply means, it doesn't mean ordinary, it just means at 90 degrees or perpendicular to the surface. 100 years ago, if you went to school in Canada to try to learn how to be a teacher, you'd go to something called a normal school. So we use words in various different ways. The word translate is used in a number of different ways as well. If you have something in one language and you're trying to move it to another language, but keep the meaning the same, you would translate it. In biology, if you want to make multiple copies of a protein using mRNA, that you would translate those things to get the new copies. In biology, it's called translation, where you're making identical copies of proteins. And in mathematics, we use the word translate to mean if you've drawn something, you've drawn a shape like this purple one here, this purple parabola, and you're moving it to a new place on the graph without changing its shape or its size, you're just simply shifting it this way or shifting it this way, then you are translating this function or translating that shape from one place to another. That's what it means to translate. If you want a memory aid, then think of it this way. Let's say you're going on public transit. You're going on public transit like a bus or a train, and you're being moved from one place to another, and the public transit's not changing your shape. Your shape is changing the same. You are being translated from one place to another place, but keeping your shape the same. That's also another valid use of the English word translate. So we're going to be start by looking at some translations. We're going to be doing, these are called horizontal translations. What that means is, this is the horizon. Think of the horizon. If you're looking at the horizon, it's flat up ahead of you. This is the horizon here, and we're translating things along the horizon. That means they move straight left, straight right, or straight left. And then here's something, the purple one is being translated upward. This is called a vertical translation. Like in basketball, if you jump high to shoot the ball, that means you have a high vertical. So translating up and down is a vertical translation. We're going to be doing a couple of examples in this video focusing on vertical translation. So give me a second. I'm going to redraw some pictures for you, and then we're going to do some examples for you. See you in 2 seconds. Okay, I'm back, and I've sketched a couple of functions for you. Two very straightforward functions. First of all, here is an x squared function. Maybe I've stretched out a little bit here, but I wanted to make it a little clearer. So here's y is equal to x squared. That's the purple one right here. So this is the original one, which is a very, very simple function. You just go like this, basically, and if for every x value here, let's say x is 1, y is equal to 1. When x is 2, y is equal to 4. So if we did a straight chart here, x and y, the original one is 0, 0, and then 1, 1, 2, 4, if this is x squared. You just take the value here that you have for x and square it and put that in there. So the purple one is your original x squared function. Now what if we say we want to draw this yellow one, we want to raise the whole thing up by 2. We want to take everything and lift it up. We want to translate it. Remember we talked about translations? We want to translate the whole thing, keeping the shape the same, but just shifting it upward. We'll add 2 to this side. So we're going to take x squared and just add 2. So in other words, for whatever the value is of x, we plug that in. That's going to give us a y value. That's going to give us a y value right here. And then we add 2 to it. Just like that. So whatever the y value is here, we'll add 2 to it and get that point. So in each case, we're going to get a new point, and we're going to take the entire thing and just shift it upward. Just add 2 to the entire function gives you a vertical lift. And of course, the same thing would be if you subtract 3 from every function, it's going to give you a shift downward. So this point now, whatever the y value is here, is going to be shifted down. So for that same x value, you're going to shift down by 3. So this is very, very simple. This is an x squared function. It's quite straightforward. I've drawn another one for you over here. And here's the straightforward. Let's move out of the way a little bit. This is the 1 over function. It's the reciprocal, and it would be 1 over x, which is something like this. It goes to infinity here. This is called an asymptote. This is called an asymptote as well. The x-axis goes to infinity, curves around, goes to infinity, just like this. The original purple one I've drawn here is just like this. It's 1 over x. Now what if I want to take the purple one, just shift it up by 2. Notice the asymptote changes. The asymptote now is at y is equal to 2. So it now becomes this blue one up there, and this down here, the purple one, shifts up to become this blue one over here. Probably the one where I'm subtracting 3 is a little, just like I subtracted 3 here. I'm going to take 1 over x, subtract 3. To do that, I'm going to erase some of the other stuff here. There you go. That might be a little clearer. So I'm going to do this purple one, which is the original one, and shift everything down. So whatever, we plug an x value in here. So we take an x value. We get a y value. That is this thing over here. And then we're going to subtract 3 from that. So we'll just subtract 3 overall to give us this value over here. You do that everywhere. So what you could actually do if you have your original function, your purple one, and just sort of say visually, what would it look like if I just move it down by 3 and sketch it down here? It's fairly simple. For a function like this, it's fairly straightforward. You can probably do it visually and just realize the asymptote here, where it goes to 0, is at y is equal to 0. So you're shifting that down now to y is equal to minus 3. And notice here, it goes just like this one and just like this one. So hopefully this helps you with some of the basic stuff with shifting up and down. I'm going to give you a specific example because you can usually do these visually, or you can actually find the new sketch mathematically. I'm going to do it for you both ways. Give me a second to erase some things and just draw up a simple sine function here. Okay, I've drawn up a simple sine function for you. Notice this is the y-axis here. This is the x-axis. I've drawn dotted lines here when y is equal to plus and minus 1. The sine function starts at 0, goes to 1, goes back to 0, minus 1 here. Now let's say this is the graph, y is equal to sine x. Now what if we wanted to graph this, but we wanted to take this and add 2? So let's say I wanted to graph y is equal to sine x plus 2. Notice I could take the entire sine function and just lift everything up. Remember, translations involves taking you and moving you from one place to another without changing your shape, just like public transit. So what if we take this entire purple line, just move it up by 2 and draw it up here. So I'm just going to make a rough sketch of that. I'll maybe use a different color just so you can see it clearly. So this here is going to be at 1. So it's going to be 2, 3, 2, 3. We're going to move it up by 2, so this 0 here is going to be probably around there. This 0 is going to be around there. And then we're going to do something like this, right? Something like that. It's a little bit hard to see exactly what you're doing. You're just doing a rough sketch, and hopefully you get it pretty close on taking this and translating it up. So that's the visual way you would do it. You would sort of just do it visually and see if you could lift the whole thing up. But there's actually a mathematical way to do it. And we're going to do that next. What we're going to do is we're going to take each of these points. When you do something mathematically, you're translating it. What you do is you take some extreme points. Points where the shape changes shape, where the function changes shape, or the shape has a specific corner or something. So these points here, this one there, the ones that I've lifted up in blue there, are sort of specific numbers there. I'm going to write those out here. Give me 2 seconds. Okay, I've made this chart of these points here. You might be more familiar with the Babylonian system of angles. Well, this here is 360 degrees. This is 180. This is 90. This is 270. But usually when we do mathematics, especially more advanced mathematics, grade 11 and 12 and upward, we'll tend to use radians instead. So I've put them in radians over here. So I've taken these specific points here, these 5 points. this first one here is 0, 0, right up there. The next one is the x value is pi over 2, the y value is 1. Then it's pi, and the y value is 0. Then it's 3 pi over 2. These are the harder ones when you get into the fractions. And 3 pi by 2, and the value is minus 1 right down there. And then 2 pi, the value is 0 again. So it goes up and down from plus 1 to minus 1. Now what I want to do is I want to say, okay, the x values are staying the same, but what's happening to the y values? The x values are staying the same, but we're adding 2 to the y values. So the x is the same. I'm just going to leave that. And then the y, we add 2. So I'm going to make a new column here with these values, but just like this here. So instead of 0, it's going to be the same. So that's going to be 0. Instead of 0 here, you're going to add 2. So we're going to make that a 2. So that this point over here becomes this new point. And then this one over here, it's still going to be pi over 2. But we're adding 2. So this is going to be 3. And this is still going to be pi. The x value doesn't change because we're only shifting, or we're only translating the vertical, the up and down. We're just adding 2 to that. So this is going to be pi, and then this is going to be 2, just like it is over here. This one's going to be still 3 pi over 2, and then this one's going to be adding 2 to this. We're going to get 1, and then here 2 pi, we're going to get 2. So these points here all translate from this to this. If we translate each individual point, we can draw a better curve. So I'm going to erase the yellow I did here and see if I can redraw this a little better. Okay, I've erased some things here and drawn some fresh lines. I've labeled this original purple one here, y is equal to sine x, just so it's out of the way. And I've added some lines straight across, some dashed lines of y values. Since those appear over here, we might need those to do our sketch. So let's just do this point by point. 0, 0 becomes 0, 2. 0, 0 becomes 0, 2. I'm going to draw them in red so they're nice and bright. Pi over 2, or 90 degrees, becomes 3. Pi over 2 becomes 3. There we go. Pi becomes 2. So pi becomes 2 right there. Just move straight up, see? 3 pi over 2 becomes 1. This one becomes 1, way down there. And then this one becomes 2 again, so straight up there. So now we've drawn our different points. And the shape, remember the shape, the size, when we're doing a translation, the shape and the size stay the same. So we just have to copy now to these points that we've done our new shape. So here we go, same shape as before, but we've drawn the extremes. Of course, this would continue on before. So now this new red one is y is equal to sine x plus 2. There you go. That is a vertical translation upward by 2. Very, very straightforward and simple. Especially if you use this method, you can get a very, very exact value for the corners and then be able to sketch it in. Let me erase a couple of things. There's one more thing I want to mention, then we'll go on to the next video. So here I'm back. I've erased some things over here and just copied this function. Y is equal to sine x plus 2 over here. This is pretty straightforward to realize. We're taking whatever value we have here, whatever y value we get when we plug in an x, and just adding a 2. So we're just lifting up all the y's by 2. That's pretty straightforward. Because it's over here, it's nice and easy to see. That's why I started with that one. But what if we move this 2 to this side? Then we would have something like this. Y minus 2 is equal to sine x. That means if you put an x value in here, the y value that you're going to need now is going to have to be 2 bigger than it was before, right? Because whatever the value of x you put in here, let's say you put in pi over 2 over here, whatever value you're going to get here, you're going to have to find a value for y that's 2 higher than it would be before, because it's going to be reduced by 2 by this here. So putting it on that side is a little bit more complicated, but this is going to help us, because when we're going to do the translations in the horizontal direction, we're actually going to have those things tied in directly with the x. So just by you seeing this here, seeing we can write it like this, or we can write it like this. This is the more straightforward way, the way that we can visualize it. We're just moving the total y's up and down, but we can also take this 2 and move it over to here. This is going to be very helpful for our next video, so make sure you like and subscribe, and check out my next video on this same topic where we're going to do things horizontally. I'll see you in a second. Bye-bye.